23 divided by 15. So by the way, this whole review is going to be very labor intensive because you're not going to be using a calculator for this. Okay, so 15 does not go into 23. Remember, it's 23 divided by 15, okay? So 15 goes once. We have 8 left over. We're going to continue, so we're going to add a 0 and a 0. Put a decimal there on top as well. 15 goes into 87 5 times, which is 75. We subtract, we have 5 left over. We're going to bring a 0 down. 15 goes into 53 times, which is 45. And if we subtract, we're going to get another 5, and we bring a 0 down, it's going to be, it's going to be 50 again. So notice that we're going to put another 3, because 15 goes to 53 times, and we get 45 again. And that pattern is going to repeat over and over and over again. So my final answer is 1.5333333 dot dot dot, or what we know, we can write that like that because the bar notation goes on top of the 3 because the number 3 is the one that repeats. Okay, so that would be your answer. The next one is 14 divided by 27. Remember, the numerator goes inside. Does not go into 14, so we add a 0. That allows us to extend this number. So 27 goes into 14 5 times. 5 times 7 is 35. Carry the 3, 135. Subtract 5 left over. Bring a 0 down. 27 goes into 50 one time, which is 27. Subtract, we got 23. 0 down. 27 goes into 230 8 times. 8 times 7 is 56. Carry 5. 8 times 2 is 16. 16 plus 5 is 21. Subtract this. 230 minus 216 is 14 left over. And we can I can already see a pattern. Notice that the number 140 shows up again, and we started with 140. Right, so 27 goes into 140 5 times, which is going to be 135, 5 left over, and then you can see that these numbers are going to repeat again. So if we were to continue for this particular problem over and forever and ever, we would get 5185, 518, 518, because 518 will repeat over and over and over again. So our final answer is 0.518 bar notation. Okay, not too complicated so far. Okay, so next question is 12.34 bar notation minus 8.51 bar notation. So we can't subtract these as it is, so we're going to change them. Okay, to a fraction like we've done in class. So let's change the first one, 12.34 bar notation. So we're going to set this to x equals 12.34, and then we're going to multiply both sides by 100, right? So we're going to get 100x. So imagine 12.34. It's 34, 34, 34, 34 forever and ever, right? We multiply this by 100, which is going to increase this, right? It's going to get 100 times bigger, which basically means we move that decimal 2 over. So if I multiply 12.34 by 100, I'm going to get 1,234.343434 bar notation. Right, so let's write these two on top of each other so I can subtract. So let me write 100x equals 1,234.34 bar notation. And then at the bottom I'm going to write x, our initial. And I can line up my decimals, remember. Right, bar notation, I can subtract. 100x minus x is 99x. 1,234.34. Well, these will become 0, right? So eventually I'm going to have 4 minus 2 is 2, 3 minus 1 is 2. 1,222 divide both sides by 99. That's what x equals. So I'm going to write over here 1222 over 99 is the fractional equivalent of that number. Still not done. Like I said, very labor intensive. Let's do 8.51. So set x equals 8.51. Right, so let's rewrite this again. Let's multiply both sides by 100. It's going to allow me to move the decimal. So again, I'm just to the 3, what 8.51, 51, 51, 51 is, right? Multiplying this by 100 will increase that by 100. So the shortcut is just move the decimal 2 over. So we're going to get 851.51 bar notation. Now let me rewrite this so that the bigger value is on top. So 100x equals 851.51 bar notation over, the other one's x equals 8.51 bar notation. Notice that if I subtract these two we can get rid of, right? And then 851 minus 8 is going to be 843, and it's going to be 99x. 100x minus x is 99x. Divide both sides by 99, right? Because we want to isolate our variable, and x equals 843 over 99. Now I can bring that on top because 8.51, its equivalent in the fractional format is 843 over 99. Look how beautiful that is. We can subtract because they're both same denominator of 99, so we keep the denominator. And we multiply, we subtract the top. So 1,222 minus 843. A lot of borrowing here. So that's a 10, that's a 12, becomes 11, that's a 12, becomes 11. 12 minus 3 is 9, 7, 3. That one became a 0, so final answer, 379 over 99. Or we can write this as 3 and 79 plus 3, 99 over 82, if I'm not mistaken. Okay, so that would be your final answer. So if you got to here, and then change that to a mixed number. Okay, so again, labor intensive, but nothing too complicated. Now the next one says negative 2.5 times negative 2 over 15 divided by 5 over 12. So what I'm going to do is, because two of these are in fraction, I'm going to change everything to a fraction. So you got to decide. You want to change it to decimal. If it's convenient, you change to decimal. You change if you want to change to fraction. This 2 over 15 and 5 over 12, not too sure they're going to be nice decimals. Okay, so I much rather deal with fractions in this one. So let me change this to a fraction. So it's negative 25 over 10, right? 2.5 over 10. So this actually becomes negative 2.5, right? It's over 10. Let me write 2.5 on top. But I don't want that decimal on top, so to get rid of this decimal over here, I'm going to multiply this by 10. I get 100. If I multiply 22.5 by 10, I get 25. And that's how I got that number. Let me erase this now. And then that's being multiplied by negative 2 over 15. So now this over here, by the way, is a division problem, correct? So what I'm going to take advantage is change it to multiplication. Right, so we can change that, and it's going to be 2 over 15, right? And then multiplied by the reciprocal of that, which is 12 over 5. So now it's just 3 fractions being multiplied, and if I can, simplify things, make my life easier. So let me pick 5 divided by 5 is 1, 25 divided by 5 is 5. Let's see what else I can simplify. I can simplify this 5 and 10. 5 into 5 is 1. 10 into 5 is 2. This 2 and this 2 goes away. 12 and 15 I can divide by 3. So 12 divided by 3 is 4. And 15 divided by 3 is 5. So notice that deal. I have left a 1. There's a 1 here. So on the top it's going to be a 4. Because 1 times 1 times 4 is 4. And at the bottom, 1 times 5 times 1 is 5. And then we have a negative times a positive, and that's going to be positive. Okay. Determine the sum. So we're adding these two. Minus negative 5 and 7/8. I will change this to an addition problem first. Okay, remember, we change subtraction to addition, and the opposite of negative 5 and 7/8. And again, make a decision. Can we change this to decimal? I wouldn't, because they're going to be not nice decimals. So I just keep it as it is. I do need to, find the common denominator. So let me change this to an improper fraction. 9 times 2 is 18. 18 and 8 is 26 over 9. Plus 840, 47 over 8. Right, now I can find the LCM, which is 72, I think, yeah, 72. So we're going to change both fractions to its equivalent form with a denominator of 72. So how did 26 over 9 become, how did this 9 become a 72? We multiplied this by 8. So if I multiply the bottom by 8, I got to multiply the top by 8. And I get 48 goes 4, 16, negative 208. How did the 8 become a 72? Times 9. So I multiply the top times 9, which is 3, 6. 36 plus 6 is 423. Well, it's a negative plus a positive, right? So imagine that the denominator is not there, so just cover that up. So it's a negative 208 plus 423. There are more positives, right? So the absolute value of this is bigger. So we'd have to subtract those two numbers. Then we get 13 minus 8 is 5, 1, 215, positive. And if you left it there, I would give you 2 points. If you want to change it to an improper fraction, a mixed number, you can. I just not going to do that. Okay. Evaluate. Ugh, yuck. So I think that says 4/5 minus 3/7 over 1 over 20, and then subtract 0.5 with the bar notation. Great problem. Yikes. All right, so just because it's bothering me, I'm gonna do the 0.5 first. So x equals 0.5 bar notation, and then we're gonna multiply that by 10 because there's only one number repeating, right? So multiply that by 10. And multiply that by 10, I can get 5.5 bar notation. So let me just rewrite these two. Okay. I'm going to write 10x on the top, 5.5 at the bottom, x 0.5, right? So basically I just put the 10x on the top to make it easier to subtract. 10x minus x is 9x. These goes away, right? And 5 minus 0 is 5. Divide both sides by 9, x equals 5 over 9. So 0.5 with the bar notation, repeating, right? It's a repeating decimal. Its fractional equivalent is 5 over 9. Okay, so now the rest is just, whatever you learned in 4th grade. So it's just subtraction fractions. So let's do the top. So 1 over 20 is going to just stay and relax for a little bit. 5 over 9 is going to stay. We got to take care of that. So 4/5 minus 3/7. Shoot. Let me just do it over here. That's 35, 28, 15, right? The LCM is 35, right? So I'm going to change one fraction to 28 over 35, and the other fraction is going to be 15 over 35. Subtract those two. I'm going to get 35, and 28 minus 15, it seems like it's 13. Okay. Now, this is a fraction on top of a fraction, so you can actually write it like this. 13 over 35 divided by 120 minus 5 over 9. Okay, so you can change the division and rewrite it as a multiplication problem. Times 13 over 20, 13 over 35 times 20 over 1 minus 5 ninths. So now we have, we can simplify these two. Divide 20 by 5 is 4. 35 by 5 is 7. So at the bottom we get new denominator, 7 times 1 is 7. And on the top we get 52. And that minus 5 over 9. Find an LCM. The common LCM here be 63. Right, 57 over 7. Its equivalent in 63rds would be, times 9 here. So I got to multiply that times 9. 18 goes 1. 45, 46, How did the 9 become 63 times 7, and then times 7 here, you get 35. So final answer, something over 63. Looks like it's 433. And I'm not changing this to a mixed number because I think that's enough. Okay, so moving on. Oh, geez, negative 2 to the, no, minus. Okay, we gotta be really careful with this problem. Let me rewrite it nice. It says minus 2, 4 times minus 1 over 1 plus 1 over 1 half. Okay. Let's take care of this ugly stuff here. Now remember, there's a big difference. There's a reason why this problem is here. This one says minus 2 to the 4th power. So the 4th power is just affecting the 2 here. It's not raising minus 2. So the minus is just outside here, relaxing and waiting. What's 2 to the 4th power? It's 2, 4, 8, 16. So that becomes this. Times, and now this is different because the parentheses has the negative 2 inside. So guess what? Everything inside the parentheses is raised to the 4th power. So in this case, you're actually multiplying negative 2 times negative 2 times negative 2 times negative 2, which gives you positive 16. Okay, and do I have Alexa here? Alexa, what's 16 times 16?
16 times 16.
256. All right. So this whole thing becomes negative 256, right? Because that was a positive, and that was this. Okay. So now that gets to wait a little bit, and we have to take care of this whole mess here. Minus. So slowly allow me to change 1 plus 1 plus a half. Let me rewrite that as 1 and a half. Right? And what's 1 and a half? 1 and a half as a mixed number is 3 over 2. Correct? So I'm going to do this in step for you guys. Oops. So I move up. So now, right, so I'm going to step by step like that. Minus 1, and then 1 plus, and let's take care of this. This is 1 over 3 over 2, which is the same thing as 1 divided by 3 over 2, which in terms becomes 1 times 2/3. Right? And what's 1 times 2/3? It's just 2/3. So this whole thing over here, and hopefully I can highlight, this whole thing over here is the same thing as 2/3. So now we have negative 256 minus 1 and over 1 plus 2/3. And what is 1 plus 2/3? 1 plus 2/3 is 1 and 2/3. Right? So negative 256 minus 1. And let's change this to an improper fraction. 3 times 1 is 3. That becomes 5/3. And again, let's take care of this part, and that's the same thing as 1 divided by 5/3, which is the same thing as 1 times the reciprocal, which is 3/5. So again, let me highlight this whole thing. That's not a highlighter. This whole thing is the same thing as 3/5. So we can go back here and write 256 in blue, minus 3/5. Right? Because 1 times 3/5 is 3/5. So that's what we have right now. And then we just need to subtract. This is over 1. The LCM is 5, so we got to change the fractions to a denominator of 5. So 1, how did the 1 become a 5 times 5? So I need to multiply the top times 5. 5 times 6 is 30. 328 goes to 1,280. Minus, right? So don't forget the minus sign. You want to change this, but this is going to become to an addition problem. That stays. that changes, and that changes to its opposite. The denominator stays, and it becomes 1,283, right? Because they're both negatives, so we actually end up adding those two, right? And attach the negative sign. Where are we? Question 7. So the area of a playground is 76 and 3/4 unit squared, whatever the unit is. The width is 20 and a half. The length I don't know. The width is 20 and a half. So if the area, well, we know the area is length times width, right? So let's substitute. Equals length times 20 and a half. So we're looking for the length. So what number multiplied by 20 and a half would give us 726 over 34. So we can rewrite this as this. Right? So divided by 20 and a half, that would give us our length. Correct? So that's just, again, a matter. So I personally, if I were you, would change this to mixed improper fraction. 2 times 20 is 40, so that would be 41 over 2. This one is 726 times 4, which is 24, goes to 29. 4 times 726 is 2,904, plus 3, 2,907. So we get 2,907, right, over 4. Okay, so now it's just a matter of multiplying 2,907 over 4 times 2 over 41. Let's see if we can simplify this. Yes, this and this can be simplified. Can 2,907 divide by 41? Just to see if I can simplify that. That would be a miracle. Let's try 7. 7 times 1 is 7. 7 times 4 is 28. 3 left over, 3 like that. You know what? If this was a test, I'll just ask you to leave it as 2 times 41 is 82. 2,907 on top. I'm going to try one more time to simplify that. No, you can just leave it like that. Units squared. I'm sorry, it's feet, not even squared. Sorry. We want to find the length. So the length is 2,900 over 82 feet. And you know what? It's bothering me, so I'm just going to change that. 3, 6, 24. 10 minus 6 is 4. 8 minus 4 is 4. 4, 47. Let's try 5. 10 goes 1. 40, 41. 3, 7. Let's add a decimal. Bring a 0 down. 82 goes into 370 4 times. 4 times, which is an 8. 32, 33. 10 minus 8 is 2. 6 minus 3 is 4. 420. You know what? I don't want to continue too much, but let's put a 5 over here. 5 times 2 is 10. Carry 1. 5 times 8 is 40. Plus 1, 410. Sorry. So we're going to have 10 left over, and we're going to stop right here. So it's approximately 35.45 feet, the length. Okay, if you were to divide it. But if you left it like this, I would completely accept it as well. Okay. So Johnny has 3 boards measuring 8 feet. So this measures 8 feet. Okay, so this measures 8 feet. This measures 8 feet. And he's going to cut them in pieces of 2 3/7. how much leftover will he have? Oh my God. So, all right. So first of all, this is the, oh, I remember this question. So this is a tough one because do we know that he's putting the boards like that and making it one single board or not? So it really depends on how you read this question. When I read it, okay, it's 3 individual boards. So I'm gonna divide 8 by 2 and 3/7. So how many 2 and 3/7 pieces can I make out of one board? Well, out of one board, let's see, so divide 7 times 2 is 14, 14, 17 over 7. We're going to change this to a multiplication, so 8 times 7 over 17. What ugly numbers. That's 56 over 17. And we can make I'm sorry, 17 goes into 56 3 times, which is 51. 3 and 5/17. So I can make 3 boards and 5. So I can make 3 boards. I can make 1 board, another board, and another board. 3 pieces of 2 and 3/7. And how much am I gonna have left over? I'm gonna have 5/17 of a foot left over. So if I repeat that process with a second board, again, I'm gonna have 3 pieces that measure 2 and 3/7. And I'm gonna have 5/17 left over. If I do that on the third big board, I cut it into 2 and 3/7, 2 and 3/7, 2 and 3/7, and guess what I have left over? 5 and 17. So I have 5/17 left over in each of the boards. So if I multiply that by 3, I get 15 out of 17. 15/17 of a foot, not feet, sorry, of a foot left over after I finish this process. Okay. Okay, so Taylor used what string? So she used 22.5 yards, 78.35 feet of green. So this is blue, green, and 900 inches. Oh, jeez, of pink. How much is left over? She starts with 108. How much is left over? She started with 189.76 feet of string. So if that's what I started with, I got to subtract minus 22.5 yards, minus 78.35 feet, and minus 900 inches, right? So the problem in this question is that except for this one, except for the middle one, which is in feet, the other two are in yards. So you got to make a little conversion. So how many yards? How many feet in a yard? It's 3, right? So 1 yard is 3 feet. So we're gonna have to change by multiply 22.5 times 3. 15 goes 1, 7, 67.5. So 22.5 yards. I'm gonna rewrite this. 67.5 feet. This one at the bottom is 78.35 feet, so we're good here. And then 900 inches, we got to change it to feet. So we know that 1 foot has 12 inches, so we actually have to divide 900 divided by 12, which is going to be 7. 84, 75, it looks like 75 feet. Let me double check. 84, 60, yeah, it looks like 75 feet. So 900 inches is 75 feet. So we can add all three and find out how much was used. So it looks like 5, 8 goes 1, 16 plus 5 is 21, goes 2. We got 14 and 6. We got 221.85 feet were used. And the question doesn't make any sense because if you started with 189.76, how did you use 221.85? So whoever made the question, probably me, should have upped this number by a little bit. But if you got this far, well, if we actually, let's continue because we're going to get a negative number, maybe negative yardage, negative feet, or however that means. Maybe I borrowed, or this person, Taylor, borrowed some from somebody else. So it becomes 189.76 plus negative 221.85, right? So we have to find out how much. It's going to be negative something, and let me scroll down. So 221.85, 189.76. Let's subtract. 15 minus 6 is 9, 0, 11 minus 9 is 2, 11 minus 8 is 3, so negative 32.09, 32.09 yardage, right, because she had to borrow from a source to complete whatever it is that she's making. Okay. All right, so, and then we have quite a few more. 10, so this is the pumpkin question. So last year, pumpkin weighed this much. This year we want to grow it we want to increase its size by 1 1/5. Okay, so we're going to multiply that by 1 1/5. Okay. And then she's going to, for whatever total that becomes, we're going to take 3/5 of that, because that's how much we're going to use to make pie. Okay, so in a sense, what I'm trying to say is we can make this a long expression right like that. I need to bring my charger. Give me a second. Yes, I almost tripped. Okay, just in time, sort of. Okay. All right, so now it just becomes a matter of how you want to do this. So do you think it's easier to, this one is actually, might not be a bad one. Well, to do it like this, times 0.6, right? So really up to you. Bummer. I'm going to, let's see, 5, 6 over 5. I don't see any advantage either way to do this. Okay, so I'm just going to keep it as a fraction. All right, so 2, 2, 2, 2 times, right? So let me put that times somewhere in the middle. 6 over 5, which then we're going to take, right, and multiply that by 3 over 5. Can we simplify anything? Absolutely not. So we're going to get 25 at the bottom. That was easy. And then on top, it's going to be 222 times 18. I guess that's not that bad. 6, 17, 17 again, and then finally 17. And then at the bottom it's going to be 2, 2, 2, 2. It's 6, 9, 9, 9, 9. So we're going to get 3,000. All right, 39,996. I'm going to divide that by 25. I think it's fair that if I'm asking you to do it, that I should do it myself. 25. Subtract, I get 14. Bring the 9 down. So that's going to be 5. Not, wish it was 6. So 5 is going to be 125. 4, 24. We're going to bring, right? We're going to bring this 9 down. And that's going to be 4, 8, 9. 9 times 5 is 45. Carry the 4. 18 plus 2 is 22. With 4 left over. 2. Bring the 6 down. And again, it's going to be a 9. It's going to be 225. 1, 2. Let's add a decimal. 210. 210 is going to be 25 going to 210 8 times, which is 200. Then 10 left over. Bring a 0 down. And 25 goes into 100 4 times. So there's my final answer. So the amount that she's going to use to make pumpkin is going to be 1,599.84. Did I say labor intensive? Yes, I did. Okay, so length of a rectangle is 1 7/9. So area is length times width. The width is twice the length. So the width is twice the length, so it's 2 times, let me put this in parentheses. Okay, find the area and the perimeter of the rectangle. Yikes. So let's find the area first. Okay, so the width is 2 times the length, so let's multiply 2 times the length. So the length is 16 over 9. Multiply that by 2. I'm going to get 32 over 9. And I'm just going to leave it as an improper fraction. Actually, I think, yeah, 9 times 1 is 9, so 16 over 9. So let me rewrite this. Okay. That's 32 over 9. And I'm going to rewrite the length as mixed fraction, improper fraction, as 9 times 16 over 9. Okay. So to find the area, I would just multiply these two, right? At the bottom, can I simplify anything? What does it look like? So at the bottom will be 81. The top 16 times 32, which is 12. Carry 1, 16, 9, 32, 2, 11, 512 over 82. What's the inches squared? So that's the area. The perimeter would be 16 over 9 plus 16 over 9, right? Because it's a rectangle. 2 sides are the same length. And the other, the width, is 32 over 9, which means I have another 32 over 9. So it's something over 9. So 16 plus 16 plus 32 plus 32. It's just 32 times 3, which is 96 over 9 inches. And the other one is inches squared because it's area. Right? I'm going to leave it as improper fractions. Okay, because I'm too lazy to change it. What's happening? So I will probably tell you to divide this into 2 days, as you can tell. So number 12. Okay, so 12 is easy, right? Negative 8 is a rational. It's an integer. It's an integer rational. That's it. 4 over 7 is a rational number, and it's an integer. No, you don't need to write real because everything is real. Square root of 144 is a counting. It's a whole number. It's an integer, and it's a rational number. Okay, because square root of 44 is the same thing as 12. And then square root of 21, square root, there is no, I mean, it's a decimal, right? So again, if you have the biggest calculator in the world and you typed in square root of 21, it'd give you a decimal number that would go on and on and on and on forever and ever. And because we can't write that decimal that goes on forever and ever and ever and doesn't repeat, we can't express it as a ratio of two integers. And if we can't do that, it means that the number is a rational number, right? Remember that definition of rational number. Okay, rational number can be expressed as a ratio of two integers, and we can't do that with square root of 21. Okay. 13 is just an adding. I mean, again, it's just adding a bunch of decimals. That's all it is, and multiplying. So here we have Kim bought 2 of the Apple Watch 4. So 462.84 times 2. What else did she buy? A Mac Pro 243444. 2434. 2434.84 for the Mac. 2 tickets to Australia. Each 1,893.11 times 2. And she started with 10,000. How much? And with the leftover money, how many Dr. Dre Beats by Dr. Dre headphones can she buy? Well, let's find out how much she has left over, if she has anything left over. So the MacBook Pro stays because there's only one of them, thankfully. These two I have to multiply by 2 for 462.84 times 2. There's two decimal places here, which means my answer has to have 2 decimal places. Okay, so right, 2 factors or 2 numbers that are being multiplied has a total of 2 decimal places. So 2 and 4 is 8, 16, 5, 12, 9. 2 decimal places makes it 925.68. The trips to Australia, 1893.11 times 2. Again, the 2 factors have 2 decimal places. So our answer has about 2 decimal places. So it's going to be 2, 2, 6, 18, 17. Carry 1 is 3. 3,786.22. And we need to add all that up. Okay, so remember that when we add decimals, we need to line them up, right? Because we need to add the same place values. Right? So that's why we line up when we're adding or subtracting. 2434, 3786.22. Add them up. 14, 10, 17, 16, 14, 21, 2. So 7,146 is how much she spent. 0.74 minus 10,000. Let's see how much she has left over. 10 and 4 is 6. 9 and 7 is 2. 3. 9 and 4 is 5. 9 and 1 is 8. And 9 and 7 is 2. So she has 2,873. Ugh. How much is it? Dr. Dre's 300 and what? 350. So let's just estimate. All right, for the sake, because the question says how many can he buy. So I'm going to round this to 2,900 and 350. So I'm going to say, let's multiply 350 times 9. It's going to be too much, times 8. 0, carry the 4, 44. Carry the 4, 24, 28. So how many Dr. Dre's he can, whatever this is, headphones can he buy? He can buy a total of 8. And he'll have some left over. Okay, so the magic number is 8 items. German Shepherd weighs 50 and 1/4 pounds. A beagle weighs 3/5 of that. So we're going to take 3/5 of that number. And when you take 3/5 of something, it means multiply. There's two ways you can do this. You can do it as it is, or I don't know, you can do something like this. You put 1, 2, 3, 4, 5, divide that by 5 and find out what 1/5 is, or another fifth, you know. So we're going to divide 50 and 1/4 into 5, right? Into fifths. Find out what 1/5 is, and then add this fifth plus this fifth, and you get the beagle. So that's another way of doing it. So I'm personally, I just want to change this to an improper fraction. I get 4 times 5 is 200, times 1 is 201 over 4, times 3/5. Ugh, nothing to simplify. 4 times 5 at the bottom is 20. 201 times 3 is 603. Just because I'm curious. Let's see how much the beagle weighs. 0, bring the 3 down. Can 20 go into 3? No. But 0, add a decimal. Sorry, I added the 0 in the wrong place. Add the 0 here. Bring it down. Can 20 go into 30? One time. I have 20 left. It's 20. 10. Bring another 0 down. So the beagle weighs 30.15 pounds. The fat beagle, actually. Really fat. And 15. Oh, there's 2 more. Okay, that 2/5 divided by, automatically I'm changing that to a fraction. Okay, it's gonna be, again, your choice. You could have changed 2/5 into 0.4 and then just divide. I think you rather divide with fractions. So let's change that to this. And again, you could have well, we are going to simplify. Okay, we change to the reciprocal. Let's simplify. 5 divided by 5 is 1. 100 divided by 5 is 20. 20 divided by 5 is 4. 55 divided by 5 is 11. Is there anything I can simplify? No. Positive times a negative is a negative. 2 times 4 is 8. And 1 times 11 is 11. So we simplify everything that we can. Makes life much easier. Last question. I hope. Negative 9 2/5 minus 8.2 plus, I'm going to tell you, okay, negative 9 over 10 plus 6.35. Okay, so now all these decimals are in nice, what do you call, all these, sorry, let me rephrase. All these fractions are nice fractions because I can change them to really nice decimals, and I much rather deal with decimals in this case. So this becomes negative 9.4 minus 8.2 and plus negative 7.9 plus 6.35. So let me just, and again, if you want to change this to an addition, right? So we have 3 negative numbers here that are being added to each other, which means we're going to go further and further left on our number line. So let's just make, so we know it's going to be negative, so let's just add all 3 numbers, 9.4, 8.2, 7.9. That's going to be a 5, carry 1's 10, 25. So that's negative 25.5. And then to that we add 6.35, and then that means that the answer is going to be negative, but it's going to be a little bit closer to, what do you call it, to 0, or to the right, right? If you put negative 25 on the number, 25.5 on the number line, and we add 635, we're going to the right, right? So we're going to take a little bit, we're going to take this absolute value from this absolute value. And that's going to leave us with 25.5 minus 6.35. We subtract, that's 5. 4 minus 3 is 1. That's 5. 14 minus 6 is 8. Negative 8 point. Phew. Okay. That was a long one. Okay. Alright, but it's over. And that's pretty much what you're going to see.